Hello everyone, welcome back to my channel Geography with Sumona. I am Sumona. In today's video, we are going to discuss a very important topic in climatology, that is the structure of the atmosphere. As we know, the atmosphere is the envelope of gases that surround our Earth, but the atmosphere is not uniform throughout its entire height. Based on changes in temperature, composition and other physical characteristics, it is divided into several distinct layers. In this video, we will learn about these different layers of the atmosphere, their important characteristics and the phenomena that occur within them. So let's begin today's topic. Now let's understand how the atmosphere is divided. The atmosphere is mainly divided into different layers based on the variation of temperature with increasing altitude. If we move upward from the Earth's surface, the temperature does not change in the same way throughout the atmosphere. In some layers, temperature decreases with height, while in others it increases. Based on the pattern of the temperature change, the atmosphere is divided into 5 major layers. Starting from the Earth's surface, these are the Troposphere, Stratosphere, Mesosphere, Thermosphere and Exosphere. In the upcoming slides, we will discuss each of these layers in detail and understand their important characteristics and temperature pattern. Now let's start with the first and lowest layer of the atmosphere, that is the troposphere. The troposphere is the lowest and most active layer of the atmosphere, extending from the Earth's surface up to the tropopause. Its height it is not the same everywhere. It is approximately 8 km over the poles and can extend up to about 18 km over the equator. The troposphere contains nearly 75% of the total mass of the atmosphere. It also contains almost all of the atmosphere water vapor and most of its dust particles. Most importantly, the troposphere is the layer where almost all weather phenomena occur. For example, cloud formation, rainfall, thunderstorm, fog and winds mainly takes place in these layers. So whenever we experience a rainy day, a thunderstorm or strong wind, we are observing atmospheric processes that occur mainly within the troposphere. That is why the troposphere is often called the weather-making layer of the atmosphere. Now let's understand an important characteristic of the troposphere, that is normal lapse rate. The normal lapse rate refers to the rate at which air temperature decreases with the increasing altitude in the troposphere. I already uploaded a detailed video on this topic on my channel. Please check out. On average, the temperature decreases by approximately 6.5 degrees centigrade for every 1000 meter or 1 kilometer of increase in altitude. For example, suppose the temperature at the Earth's surface is 25 degrees centigrade. If we move approx 1 kilometer upward, the temperature may decrease to around 18.5 degrees centigrade. Similarly, at a higher altitude, the temperature becomes progressively lower. This is why we generally experience colder temperature at higher elevation. For example, mountainous regions are usually cooler than nearby lowland areas. So we can say that the normal lapse rate is one of the most important temperature characteristic of the troposphere. Now let's move upward to the second major layer of the atmosphere, that is the stratosphere. The stratosphere begins above the tropopause and extend up to approximately 50 km above the Earth's surface. Its upper boundary is known as Stratopause. One of the most important features of the stratosphere is the presence of the ozone layer, which is mainly concentrated between about 15 to 35 kilometer altitude. The ozone layer is extremely important for life on Earth because ozone absorbs a large part of the sun's harmful ultraviolet or UV radiation. In this way, it acts like a protective shield and helps protect living organisms from excessive UV exposure. The temperature pattern in the stratosphere is also different from the troposphere. Here, temperature generally increases with increasing altitude. This happens mainly because ozone absorbs ultraviolet radiation from the sun, causing the surrounding air to warm. So while the troposphere is known as the weather-making layer, the stratosphere is especially important because it contains the ozone shield that protects life on Earth. Another interesting feature of the stratosphere is that commercial aircraft often fly in its lower part. Most commercial passenger jets typically cruise at an altitude of around 10 to 12 km, which is near the tropopause and lower stratosphere. Although the exact altitude varies, the main reason aircraft prefer to fly at this higher altitude is that the air is generally more stable and less turbulent than in the lower troposphere. Most clouds and weather disturbances such as thunderstorms are concentrated in the troposphere below. For example, when you travel by a commercial airplane, you may notice that the aircraft climb above most of the cloud. This allows the flight to avoid much of the weather-related turbulence and help provide a smoother and more efficient journey. So, the relatively stable condition of the lower stratosphere make it a suitable region for high altitude commercial aviation. Now let's move further upward to the third major layer of the atmosphere, that is the mesosphere. The mesosphere lies above the stratosphere and extends approx from 50 km to 80 or 85 km above the Earth's surface. Its upper boundary is called the mesopause. In this layer, the temperature once again decreases with increasing altitude. Near top of the mesosphere, the temperature can fall around minus 90 degrees centigrade, making the mesosphere the coldest layer of the atmosphere. Another important feature of the mesosphere is that it acts as a natural protective shield for our planet. When small meteoroids enter the Earth's atmosphere from outer space, they encounter atmospheric particles and experience intense friction. As a result, most of them burn up or disintegrate in the mesosphere. For example, the bright streak of light that we often called a shooting star, it usually produced when a small meteoroid burns up as it passes through the atmosphere. Therefore, the mesosphere is important not only because it is the coldest atmospheric layer, but also because it helps protect the Earth from many incoming meteoroids. Now let's move to the fourth major layer of the atmosphere, that is thermosphere. The thermosphere lies above the mesosphere and extends from approx 80 km to several hundred kilometers above the Earth's surface. In this layer, the temperature increases rapidly with increasing altitude and can reach very high values, sometimes exceeding 1000 degrees Celsius. However, the air is extremely thin, so we would not experience this temperature in the same way as we do near the Earth's surface. An important region associated with the thermosphere is the ionosphere. It contains a large number of electrically charged particles or ions and electrons produced mainly by the interaction of solar radiation with atmospheric gases. The ionosphere is very important for radio communication because it can reflect or refract certain radio waves, allowing them to travel over long distances. It also plays an important role in satellite communication and other space-based technologies. Another fascinating phenomena associated with the upper atmosphere is the aurora. When charged particles from the sun interact with gases in the Earth's upper atmosphere, they can produce beautiful display of colored light, such as the aurora borealis in northern hemisphere and aurora australis in the southern hemisphere. So, the mesosphere is important for radio communication, space technology, and spectacular natural phenomena like auroras. Now we come to the outermost layer of the atmosphere, that is exosphere. The exosphere is the highest layer of the atmosphere. It gradually merges into outer space. So there is no sharp boundary between the atmosphere and space here. In this layer, the air is extremely thin. The gas particles are very far apart and the main gases found here are the lightest on, such as hydrogen and helium. This is also the region where artificial satellites move around the Earth. Because the air is so thin, there is almost no friction, so satellite can revolve smoothly. For example, communication satellite and weather satellite orbit the Earth in this outer region and help us in communication, navigation and weather observation. So the exosphere is the final and outermost layer of the atmosphere where the atmosphere slowly faded into space. Here is an important point to remember. We often know a word magnetosphere. The magnetosphere is not considered one of the atmospheric layer. It is different. It is a vast region around Earth dominated by Earth's magnetic field. It extends far beyond the atmosphere and helps protect Earth from the solar wind and charged particles from the sun. So we can say that magnetosphere as a protective region around Earth. Now quickly revise the important feature of the 5 major layers of the atmosphere. First, the troposphere extends from the Earth's surface up to approximately 8 to 18 km. It is the layer where almost all weather phenomena occur and contains most of the atmosphere water vapor. Above it is the stratosphere, which extends up to about 50 km. It contains the ozone layer, which absorbs harmful ultraviolet radiation and protects life on Earth. Next is the mesosphere, extending from about 50 to 80 km. It is the coldest atmospheric layer and is important because most incoming meteoroids burn up in this region. The thermosphere extends above the mesosphere. It contains the ionosphere, which is important for radio communication and is also associated with spectacular auroras. Finally, we have the exosphere, the outermost layer. Here, the gases are extremely sparse and the atmosphere gradually merges with outer space. Many artificial satellites orbit Earth in this region and beyond. So each atmospheric layer has its own unique characteristics and plays an important role in making Earth as a suitable planet for life. Together, this layer acts as a natural protective system for our planet, influencing weather, protecting us from harmful radiation and meteoroids, and supporting modern communication and space technology. Thank you so much for watching this video. In today's lesson, we explored the structure of the atmosphere and learned about its 5 major layers. If you found this video helpful, please like, share and subscribe to my YouTube channel Geography with Sumona for more interesting and educational geography videos. See you in the next video. Thank you once again for watching.